Let's work problem 74 from OpenStax University of Physics, Chapter 7. So we're asked to find the power output of an elevator which lifts a 2500 kilogram load, a height of 35 meters in 12 seconds. We are told that it also increases the speed of the system from 0 to 4 meters per second, where the mass of the entire system is 10,000 kilograms. So the system probably looks something like this. You would have a motor that lifts an elevator, and at the same time that it lifts an elevator, it lowers or raises some heavy item here. That's the counterbalance. So the power is the rate of change of energy. And here we're going to be finding really the average power. Now, what is the change of energy? Well, the energy changed in that 25 kilograms were raised in height, a total height of 35 meters. So the change in energy will be your change in potential energy plus your change in kinetic energy plus whatever work is done. Now, since we're not given any friction or something like that, we will not be having any work done in the system. Then my change in energy will be equal to my change in potential energy. Only 25 kilograms are raised in height. That means that would be the mass, mg, times the gravitational constant, times the height, plus the change in kinetic energy. Now the entire system is accelerated. So that's going to be 1/2 the mass of the system times the change in speed squared. So that should just be the 2500, because that's the only part that's actually raised. And the units will of course be joules. Let's put that into the calculator. 2500 times 9.8 times 35, that'll be 157,500 joules plus 1/2 times 10,000, that's 5,000, times 16, which is 80,000. So my change in energy is equal to 937,500 joules. Now this happens over a time of 12 seconds. So then delta E over delta T, which is going to be equal to my average power, will be equal to this number, which is joules per second, which will give me watts. Alright, we could put this in kilowatts. So it'll be 78.1 kilowatts. Okay, now let's find how much it costs to perform this operation. We're given that the cost of electricity is $0.09 per kilowatt hour. Now, what is a kilowatt hour? It sounds like a measure of power because it's got the word watt in it, but it really is a measure of energy. 1 kilowatt hour is equal to 1000 watts times 1 hour. Well, that's equal to 1000 joules per second times the number of seconds in an hour, 3600 seconds. That's 60 minutes times 60 seconds per minute. So 1 kilowatt hour will give me 36, and then let's see, I have 1, 2, 3, 4, 5 zeros. Joules. Now I know the joules that my operation needed, so now it's just a matter of converting this energy into cost. So I have the cost is 0.09 per kilowatt hour, so it's $0.09 per 3.6 million joules. Let's put the units like this. That's $0.09 per kilowatt hour. Which is this many joules. And so if I multiply that times the number of joules that I used, which is 937,500. I see that the joules cancel, and I will be left with only dollars. And so finally, the answer that I get is that the cost is going to be 0.234. No, 0.0234. So about 2 cents. Okay, I hope that helped.